Hello everyone, welcome back. So this is James. I'm a computer science graduate turned teacher, and in this video we're going to look into chapter 12 of A-level computer science, algorithm design and problem solving. So just want to give you a big picture of the chapter. First of all, we'll define what computational thinking is and how we can use algorithm to solve problems, especially programming problems. And then we'll look into what are the different ways that we can express an algorithm, followed by the various constructs you need in forming an algorithm to solve a solution. We won't go into programming yet, but think of this chapter like the grammar you need to write an essay. It will prepare you with the knowledge to learn programming better in the next few videos. So before we go into the main topic, just want to remind you that you can subscribe to my channel. So let's try to push to 30%. That is 30% of my viewers subscribe to my channel. So this is the only favor that I'll ask from you. Thank you so much. So let's define computational thinking. It is a problem-solving method that involves breaking down complex problems into smaller, more manageable parts in a way that a computer or human can understand and solve. So it involves the following skills, which we'll look into what is the definition of each and apply them into a real life scenario. So first of all, let's look at abstraction. It means focusing on the important information while ignoring unnecessary details. So we are abstracting information we don't need so that we can focus on the main problem first. Decomposition, in my opinion, this is the biggest life-changing technique I learned that is useful as a computer scientist, which is decomposition. Breaking down a complex problem into smaller, more manageable parts or steps. You might be wondering why do we need to break down the problem? That's because a programming problem in real life can sometimes be very difficult for us to solve it in one attempt. So this is why we need to break it down into multiple parts to solve it easily. Data modeling involves organizing and analyzing data. Pattern recognition, identify similarity or patterns within a problem to simplify understanding and find potential solution. Algorithmic design, this is what we'll be doing in this video, developing step-by-step instruction or algorithm to solve the problem. So an example would be to design a recommendation system for an e-commerce platform. For example, Amazon. How do they know what products to recommend to you? Similarly goes to YouTube. How do they know which video you might want to watch, and how do they decide that? So these are the 5 techniques that they might be using. Abstraction. They might simplify user profiles with key attributes like user ID, purchase history, and product views. What products have they looked into? And abstract other information that is not important in solving this issue, like product data, when is the manufacture date, which is not important in this case. So that's abstraction. Decomposition might be that they need to identify tasks that need to be done to create this platform, like how do they collect data, user profiling, algorithm selection, which machine learning algorithm they're going to use to create a recommendation system. Data modeling, this is pretty straightforward. We talk about it in databases. What structure do they use to store all the data they want to collect? Pattern recognition, analyze user behavior for preferences based on past purchases, view item, and search history. And by using pattern recognition, a lot of the recommendation can be done. Algorithmic design, develop algorithm to process user data, which is like a pipeline. Where do you collect data and how do you use it to recommend product? So we have talked about algorithm many different times. What exactly is an algorithm? So this is the main topic for our video today. So let's first define it, and then I'll give you a silly example. It's a set of well-defined instructions designed to solve a problem or accomplish a task. For example, making a peanut butter and jelly sandwich. And to do that, these are the series of steps you need to know. Collect bread, peanut butter, first gather the material, put 2 slices of bread on the plate, use the knife to spread out the peanut butter. Use a different knife to spread jelly so that you don't have a mixture. I don't know. Press the 2 slices of bread together. and use the knife to cut the sandwich. So these are the steps that we don't think about, right? Because they are habits already. But what algorithm can do is to specify the steps in a very detailed manner that everyone can apply this step and make a peanut butter and jelly sandwich. One thing about algorithm is that you can put steps within a steps, like a sub-step. For example, step number 3, use the knife to spread peanut butter. These are the potential sub-step. You need to open the peanut butter jar, dip the knife into the peanut butter, and then only you spread it. So this is something that we'll be looking into. So first you have a programming problem that is very big. You break it down further into a series of algorithms, and you find out that within the one step in the algorithm, you can still break it down further. So this is what we'll be learning. And you might be wondering, why do we need to learn about algorithm? So it is important in computer science because they emphasize on step-by-step procedure or instruction in order to solve a problem. Look, a computer like that, they don't have the ability to think. If you want it to accomplish something for you, you need to provide a step-by-step solution for it, and as detailed as possible, so that the computer knows what exactly is something that you want it to do. And this is algorithm. And of course, there are multiple ways we can express an algorithm depending on what problem you're solving. You can either use structured English. It's a method of expressing algorithm with natural language. Just like what I showed you in the peanut butter example, that's structured English. And a more useful way of expressing algorithm is called pseudocode. Pseudocode is an informal, high-level description of a computer program or algorithm using a mixture of natural language and basic programming language concepts. Think of it like a programming language that doesn't follow any particular syntax, and yet they use English to express the algorithm. So that's what we call pseudocode, a mixture of English and programming concepts, but not both. Next is flowchart. It's a visual representation showing the sequence and logic of an algorithm. So we will be focusing on how to write pseudocode and how to draw a flowchart to express the algorithm for a problem. This is important to understand before you move on to programming, because it prepares you with the computational thinking mindset you need to solve a problem. So now we know how to express an algorithm, but we also need to understand what are the constructs that we need when writing an algorithm. Assignment, sequence, selection, iteration, input, and output. For each of these constructs, we'll learn how to use them in pseudocode and how to use them in a flowchart. So let's go through them one by one. So this is what I'm going to do: construct, description, how to write it in structured English, pseudocode, and flowchart. First of all, input. Input means that you are asking the computer to ask the user for an input in your program. So it could be like you want to ask for a value. Then in English, you could do input X. In pseudocode, you could add a prompt to your input, meaning you show on the computer to the user what is X. Then the user will have to enter the value of X into your program. And then this value will be stored in a variable, which we'll discuss what's the variable in a while. As for flowchart, you can see that the stuff we put into the box here is the same. The only thing that I want you to remember is the symbol diagram for flowchart. It's a parallelogram. It's not a rectangle, it's a parallelogram. Same goes to output. If you want to output the result, output the content of a variable to the computer, you can use the output keyword. It's the same in pseudocode and structured English, and also the same in flowchart. And again, we're using parallelogram for input and output. So now, let's look into what variables are. This is the key item in an algorithm. Variables are needed in programming to store and manipulate data, allowing for dynamic and flexible handling of information within a program. I like to say this, that is, think of variable like a box to store data. And this box has a name, and this is what we call a variable identifier. So in this case, I'm saying the value of X here has value 5 in this variable. So variable name should contain no spacing. For example, my name is James. If I want to store my name into a variable, and when I name the variable, the variable should have no spacing, even though I ask for 2 words. Naming of the variable should reflect the variable used. See, this variable is used to store names. I cannot put a name that is irrelevant to what is the content stored. For example, it's weird for me to put like XXX equal to James, because people reading your algorithm and your code might not know what XXX is. So, but if you put first name, your colleague will know that this variable is for my name. And then here is some of the convention. Camel cap. Look, camel cap means that since that space is not allowed, we can capitalize the first letter of each word in the variables to, just make other understand this is a 2-word thing. All right. So that's what we call camel cap. And once you understand the concept of variable, you can assign a value to a variable. That's what we call assignment. Assigning a value to a variable. And for example, if you want to set x to 12, you can just do x arrow 12 in pseudocode. And in Flowchart, just use a rectangle. Write down set x to 12. Or you can write x arrow 12 as well. Both are correct. And then, of course, you can also increment the value like that. So y equal to y plus 1, which I will talk about it in a while. Another thing about this slide is that sequence also matters. The execution of instruction has to be in order, which we'll look into the importance in a while. So these are some of the stuff we can do in our program, in our pseudocode. So let's say you assign the value 5 to a variable called y. And later, you want to update the value. You want to increment it by 1. So think of it like a box perspective. You have to take out the value 5 and then add 1 to it, and then put the result 6 go back to the box. So this is exactly what we will do. I'm taking y out, add it by 1, and reassign it to the variable y. And after the increment has been done, the variable y will contain 6, right? So that's how we update a value. Copying a value is the same. Let's say I want to copy the value of y to another variable called z. I will take out whatever that is inside y and then just put it into z. So look, this is how I do it, assigning the value of y to z. Swapping two values can be a bit complex. Look, at first glance, it might seem that, nothing wrong with that, y to z, z to y. But remember, computer execute instruction in a step-by-step manner. That means they execute line 1 first, then only they execute line 2. If I were to do that, like y equal to z, look, the value of y will be whatever that's inside z, meaning I'm putting 10 into a value of y. So now, both variables contain the value z, and z cannot, the value of y cannot be copied to z because its initial value has been overwritten. One thing we can do to solve this issue is to create another variable called temp. So first of all, I'm putting the value of y before it is overwritten. I'm putting the value of y to the temp variable. And then I let y to have the value of z, meaning I put 10 into here, y. And then I let the z value to have the value inside temp. So by creating an extra variable, we can swap two values successfully. So that's the correct way of doing it. Tick. Now, following the video after that, I will continue to introduce construct, but I'll also show you some work examples to help you understand how to use these constructs. And feel free to try to solve it first before I review the solution, because I think that's the best way to learn. Make your brain think so that when the exam comes, you don't actually need to prepare much. So let's look into this work example. Write a program that asks the user for a Fahrenheit value, convert that value to degrees Celsius, and output it. Look, it involves a few constructs that we have learned. Look, ask the user for an input, meaning we must use the input construct, convert the value to degrees Celsius, and output it, again, another construct. So these are the variables we need to store the value, the Fahrenheit value, and also the Celsius value. And we'll use this formula to solve the issue. So the solution in terms of flowchart is this. First of all, when you are drawing a flowchart, remember to always start with the terminator symbols. It's a round circle, and start with an N, followed by input. Ask the user to enter a Fahrenheit value, and then you will calculate the Celsius value. Look, this is how I do it. I create a Celsius variable, and the value of it is whatever value the user entered, minus 32 times 5/9, that's the formula, and then output the Celsius value to the computer screen. So this is how you do it on using a flowchart. And for pseudocode, it's even shorter. I first start with an input symbol, input whatever prompt I want, and then I will store the user input into a Fahrenheit variable, and then I'll create another variable called Celsius. Oops, it should be an arrow. And Fahrenheit minus 32 times 5/9, output the result. So as simple as that. So this is how we do assignment. Next construct we'll be learning is the logic statement called selection. So it will make decision in a program based on a condition. So look, when you're writing an algorithm, you want your computer program to be flexible. You want them to do different things based on different conditions. And this is how you will do it in structured English. If A is greater than B, then this line of code will be executed, else that line of code will be executed. And as for pseudocode, this is how you do it. If A equal to B, this is the condition. You have to have a then keyword and an else keyword, followed by an and if keyword to end the selection. And as for flowchart, we are going to introduce a new symbol, which is this diamond thing. So this diamond is where we put our condition, A equal to B, like here, and then followed by two arrows that leads to two different paths. If A equal to B, greater than B, you do this, otherwise you do that. And more terminology. In a logic statement, you need to have a condition like that. And what's a condition, right? A condition is one statement that consists of at least one logic proposition. We learned this in chapter 4. A logic proposition is a statement that can be either true or false. It makes sense because if your statement does not have true or false, how does the computer know which path to go, the then or the else, right? And how we usually construct a logic proposition is we use comparison operators. And these are the operators that you need to know. We learn in math, but then in programming language, it's a little bit different. A greater than B. So this is one example of comparator operator. So let's do a work example. You can write it down on a piece of paper to solve it alongside with me before I review the solution. Write a program that takes an input age from the user and output you can vote if the age is 18 or above. Otherwise, output you cannot vote yet. So how I would do it is that I'll first take an input from the user and put it into the age variable. And I'll compare the age variable if age is greater than or equal to 18. If that's the case, I will output a message, you can vote. Else, I will output another message saying, you cannot vote yet. And if, as simple as that. So this is how it looks like in a flowchart. You first ask the user for an input, and then you use a decision variable, like a diamond here, and just followed by two paths that do different things. So again, this is the power of logic statement. It allows the program to be really flexible. You know, if the user age is not greater than 18, this line of code will not be run, right? This step will not be carried out. So it's now conditional. Another example, see if you can do this with me. Take three numbers as input and I'll put the smallest number. Look, I have three numbers here. I'm just putting it out for visualization. To know which is the smallest number, I'll first compare number 1 with number 2. And whichever is smaller, I will then compare the smaller number with the third number to know which one is the smaller number. And to write it down in algorithm, First of all, in pseudocode, I'll first write 3 input statement, N1, N2, N3. I'll first compare N1 and N2. If N1 is less than N2, which is the case, right? Then I will run this statement. I will check whether N1 is less than N3. If N1 is less than N3, it means that N1 is the smallest number. So I'm going to output N1, else I'm going to output 3. And of course, if N2 is the smaller number, I'm going to do it another way around. I'm going to compare N2 with N3 instead. So in this case, I have expressed my algorithm, and it works in finding the smallest number for me. Of course, this is the solution in terms of flowchart. You can double check with what you have drawn and written to see whether your solution is correct, because this is not an easy question. Again, 3 input, decision variable. Look, I have a nested decision variable. This is what we call a nested decision variable, meaning I put an if statement inside an if statement. And you can show that by putting an indentation to it to show that. And in a flowchart, it will be right after a decision variable, right after a conditional, I'm going to another conditional to check before I output the result. Of course, when you're drawing a flowchart, especially when you're drawing decision variable, the yes and no label is extremely important, because without it, no one will know whether your algorithm is doing right or not. Next, the third most important item when you are expressing your algorithm, which is a loop. As implied by the name, a loop allows the execution of a set of instructions repeatedly until it can be 2 things. A specified condition is met, or for a defined number of iterations, meaning you set the number of times you want this line of code to repeat itself. So repeat until, we have 2 different statements for loop, actually 3, but for now I'm just going to introduce 2, repeat until, and while, do, and while. It might look very foreign, but I will show you an example how to use them. For example, take 3 numbers as input, which is the problem that we just solved, but we write it in another way. So this statement first asks the user to input smallest number, and then input the next number. So if the next number is less than the smallest number, so now the smallest number will be equal to whatever it is inside the next number. And since it's 3 numbers, I'm going to ask the user for another input. If it's less than the smallest number, then smallest number is next number, etc. If you look at this code here, it works. It works perfectly. There's nothing wrong with it. But then we also see repeated statement here. If you look into line 3 to line 6 and 7 to 11, you will see that I have repeated the same code. They are exactly the same. What if the problem asks for 100 numbers? Does it mean that I have to repeat 99 times? So this is what we don't want to do. It would be good if we can tell the program that I want to repeat line 2 to 6 2 times. And that's when the loop statement comes in. How can we repeat this part of the code as many times as we want? We use a repeat until statement. So let me go through this algorithm with you. First of all, we ask again for the smallest number. And I'm going to create a variable called the counter. The counter variable will store how many times my program has loop. And then I'm going to use a repeat until statement. And everything that is indented under this statement, these are the statements that will be repeated. I'm going to ask for the next number, and I'm going to increment counter by 1. And I'm going to do my comparison stuff. And these statements will be repeatedly executed. So meaning after NIF, now my counter is equal to 2 since I've just incremented. So it's not 10. So the program will go back to this line here and execute it again. Again. Now the counter is 3. I'm going to go back. Again. I'm going to go back. So instead of moving to the next line of code, they will just keep going back to the code under the repeat statement until when counter equal to 10, then the program will stop repeating itself and it will output the smallest number. So that's how we write and repeat until statement. And it's powerful, right? You can repeat for 1,100 times without repeating the statement again and again. And this is the way to write it in a while loop. So what we just look at is repeat until. While is a little bit special. first of all, it's the same program, but instead of repeating something until, they check the condition at the start of the program. They will ask while counter is not equal to 10, it's not equal to 10, I'm gonna do this line of code again and again and again until the end. So of course you can see that counter keeps incrementing, and when counter finally becomes 10, now counter is equal to 10, then this condition does not hold anymore, and the program will no longer repeat its statement. So this is how we use a while loop. And at this time you might be wondering, how I don't really know how to use it. This is why I provide a work example. So let's say the question is to take 10 inputs from the user and sum them up. And the obvious way to write it is to do this, keep asking the user for an input. And the challenge I want to give to you is that try to use a while loop or a repeat until loop to solve the same problem. I promise your program will be a lot shorter and there wouldn't be so many repetitive. So on my count, 3, 2, 1. So pause the video. Now let's see the solution. So this is how I solve it using a repeat until loop. Again, I create a counter variable to keep track how many times my loop has been running. I keep a sum variable. I'm just gonna keep asking the user for an input, add it to sum, add counter, until the counter equal to 10. Again, these 3 lines of code here are the codes that will be repeated again and again. So hopefully you got it right. Alright, so that's another way of writing loops. We can use repetition using a rock value. So rock value is a value that is used to terminate a sequence of value. For example, you can say the program should keep asking the user for inputs until they enter a negative number. So negative number here is the rock value. And in this case, I'm just going to input n, sum equal to n. So while n is greater than or equal to 0, meaning it's positive, I'm going to do this line of code again and again and again until the user enter, for example, -5. Now n will not be greater than 0, it will end the while loop. So this is how we end it using a rock value. So I have another program here, it's called the number guessing game. It's going to be a little difficult. I want you to try it to practice your while loop and repeat until structure. So your program should fulfill the following criteria. The player gets to input a number to guess the secret number stored. So it's a secret number game. If the guess is correct, the number of guesses made is output. So if you try for 3 times, the program will say you have tried for 3 times. So if the number input is larger than the secret number, the player is given the message to input a smaller number, like a tips. If it's smaller, the player is given the message to input a larger number. If you look at the word if here, meaning you have to use selection. Alright. You also have to use loop because your program should let the user keep guessing until they got it right. So this is how you can write it, your program in structured English, if you just want clarity. Set the value for a secret number. So what is the secret number before they guess? And repeat the following steps until correct guess. I mean, you get an input from the user, increment the number of guess by 1, compare guess with the secret number, based on the guess, determine the comment make. And at the end of the program, you output a number of guesses. So pause the video now to solve it, to see whether you can write it in Pseudocode and also in Flowchart. 3, 2, 1. So to solve this issue, we need to understand what variables we need, like secret number, what is the user guess, and how many guesses have the user made. And again, so this is how I would solve it in Flowchart. I'm doing it here. I'm just going to show you how I solve it. Secret number, let's say I set it to 0. And input, we let the user guess something. And now number of guesses is equal to 1. So if, look, this is a decision variable. If guess is equal to secret number, I'm going to output, hey, you're right. And you have taken how many guesses. But if it's not equal to secret number, I'm going to increment the number of guesses by 1. And then we'll check whether the guess is bigger than the secret number or is it smaller than the secret number. And by using the value, the result, I'm going to input, I'm going to ask the user for another input, but giving another prompt, like give a smaller number, give a bigger number, etc. And this is how you do it in pseudocode. I'm gonna break it down very, very slowly. You set the secret number to any value you like, set the number of guesses to 0, and use a repeat until loop. So I'm gonna repeat everything here until guess equal to secret number. Alright? So now this is the statement I'm gonna put inside my repeat statement. Input guess and number of guess increment by 1. You can see it's very similar to the flowchart. If guess is greater than secret number, I'll put the enter a smaller number prompt, else enter a bigger number. So it's quite simple if you know how to solve it. So another thing that loop can be used is to repeat a defined number of iterations. What we have seen so far is that our code will repeat until condition is met. But what if we want it to repeat a certain number of times, meaning regardless of the conditions, I want you to repeat 10 times, 100 times, 1,000 times. This is when a for loop comes into play. The syntax of a for loop is this. For, you use the for keyword, use a variable, assign it to a starting value. And this is the value that will keep changing as loop process until an ending value and code that will be repeated. So let's say I want to write a program that will output values from 1 to 10. Instead of saying output 1, 2, output 2, output 3, output 4, I can use a for loop, and I'll do this. Because the initial value of counter is 1, when I output counter, I'm gonna output 1. And what's so interesting about for loop is that when you do next counter, you do the keyword next, it will increment the value inside counter variable by 1. And now counter will have the value of 2. I'm gonna go there. Since it's not 10 yet, I'm going to repeatedly execute this statement, output counter, output 2, output 3, output 4, until the value 10. So this is how we use a for loop, iterate for a fixed number of time. And this is another example. Take 10 numbers as input, and output the sum of this number. So I'm first going to create a variable called total. Again, I'm going to use a loop for counter 1 to 10. I'm going to ask the user for a number, and I'm going to add this number to the running total. And I will do this statement, line 3 and line 4, for 10 times because I'm using a for loop. And until the end, I'm going to output the running totals and the average. So this is another way you can use a loop to solve a problem. Nested loop. A nested loop is a loop containing another loop. So this is a normal loop that we have just talked about, a for loop. It will output the value 1 to 3. So what if I want to output the value 1 to 3 times? Meaning I want to loop inside a loop. I'll first run it for 3 times, and then within those loops, I'm going to run it again. So this is what I can do. Look, I can create an outer counter equal to 1 to 3, and then I will end it and when the outer counter equal to 3. But what happened is that I'm putting a for loop inside a for loop. Meaning, I will run this 3 times, 1, 2, 3, until I move on to the next one. So, when you're writing a nested loop, you need to use indentation to signify the inclusion of loop. So this is wrong. You need to write it in this way. Hopefully in chapter 14 or 13, we'll see how we can use nested loop better because it's not a concept that I can explain using slide. Alright, thanks. That's about it. Let me know if you have any question. So another way you can solve a nested loop, see you can solve it on your own. Write a program that uses nested loop to create a multiplication table like that. Meaning your program should output multiplication table, from 1 to 10, not 1 to 5, 1 to 10. It should do this. To break this problem down before you start solving it, just know that this is how we construct a multiplication table. You got 1 times 1, 1 times 2, 1 times 3, 1 times 4. See, 1, 2, 3, 4. This is, we can use an inner counter to solve it, right? Just loop from 1 to 10. And then, this is the inner counter. You can see that the outer counter is the same. So look, everything that is inside will always be the same. What we change after one row is that we use an outer counter. 1, 2. So, pause the video and try to solve it. And this is how I'm going to do it, the solution. So first of all, I need an outer loop that loops from 1 to 10. That's easy. Second of all, I will use an inner loop to loop from 1 to 10 again. So again, this is the outer loop, this is the inner loop. So I'm going to execute the inner loop first. And to construct the multiplication table, all I need to do is to use the outer counter value, multiplied it by the inner counter value, which is the outer counter, and assign it to result, and I'll output result. So in my first iteration will be 1 times 1, since the outer counter is 1, inner counter is 1. And then the next iteration will be inner counter equal to 2, but outer counter still remain 1. 1 times 2, so I'm going to output 2, 3, 4, 5, 6, until 10. So this is how I solve it. So I'll put a result, I put a space here so that we can get what we want here. I put a space, 1, 2, 3, 4, until 10. And at the end of it, I'll output a new line. A new line means just output on the next line. And eventually I will get the answer I want. So this is an example of how you can create a multiplication table. The code is very short, but then it works wonders. Next, stepwise refinement is another important step. Remember we talked about decomposition at the beginning of the video. So stepwise refinement is a programming methodology that involves breaking down a very complex task into smaller, more manageable tasks, like subtasks. And we're gonna learn how to use stepwise refinement using an example here. So let's say your problem is to take an input, a chosen symbol like plus, and an odd number, 7. Output a pyramid shape made up entirely of the chosen symbol, with the number of symbol in the final row matching the number input. So in this case, since my symbol is plus and the odd number is 7, you can see that this pyramid that I'm building, the last row will have 7 plus. But of course, I'm going to start off with 1, 3, 5, 7, all the odd numbers in order to build this pyramid. And to help you understand better how we can solve this problem is to view the pyramid as grids like that. And we will output spaces before we output a symbol in order to create the shape of a pyramid. But then the number of space we output will depend on which row we are in now. Okay? So this is the structured English algorithm. We are not writing skinny code yet. First of all, I'm going to get the inputs from the user, what symbol you want, and how many space you want me to, how big should the final row be. And I'm going to repeatedly do this. First, you look, I have 4 lines here, meaning I'm going to repeat 4 times. I'll first output the number of spaces, and then output the number of symbols, and then adjust the number of spaces and the number of symbols to be output in the next row. Look, the amount of space I will output in the next row and the amount of symbols I will be adding will be different. The number of space will be decreased by 1, but the number of symbols will be incremented by 2. So this is something I would need to do repeatedly. Okay, so let's identify what are the symbols that we need. First of all, we need the symbol variable. What are variables we need? Like the symbol variable, what is the maximum number of symbols, which is the user input, number of symbols, number of spaces that I should be outputting in this iteration. So I will breaking down the problem into 5 steps. I'll set up the initial value, make sure that the input is an odd number because we're building a pyramid, it has to be odd number. Output a number of space, output a number of symbols, adjust the value of symbols. So the first step is to set up the initial value. Look, this is how we solve a big problem. We break it down and then we solve subtasks. We solve the subtask. So I'm gonna ask the user to input a symbol, input max number of symbols, and the number of space calculation here is interesting. This is what I'm doing. I will use the max number of symbols minus 1 so that I can get an even number, divide by 2. This will give me the initial space that I need to have. Look, if my max number of symbols is 7, shown by this diagram here, I need 3 spaces at the beginning. And the formula to do it is to minus 7 by 1, so it becomes 6. When you divide by 2, you get 3. So this is exactly the number we want. So let's say we have another condition, the maximum number of symbols is 9. That means the first row, it needs 4 spaces. By using the same formula, look, it works for different numbers. 9 minus 1, 8. You divide by 2. Again, I got 4 here. So this is the way I determine how many spaces I should include. And then that's the first step. I set up the initial value. Second step, making sure that the input is an odd number. And in order to know whether an input is an odd number, you simply divide it by 2. And if there's a remainder of 1, meaning it's an odd number. Try every odd number when you divide by 2, you'll get a remainder of 1. And if you do even number and do divide by 2, you will not get any remainder. So this is what I'm going to do. I'm going to repeatedly ask the user to input the maximum number of symbol until I got max number of symbol mod 2 equal to 1. Mod 2 is a function that gives the remainder when x is divided by y. In this case, if it will give the remainder when max number of symbols is divided by 2. And remainder will always be 1 when an odd number is divided by 2. So this is how I ensure the user only enter an odd number. Third, output the number of spaces. We have learned for loop. Instead of doing output space, 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 you can just use the number of spaces variable, put it into a for loop, and tell the program, I don't want you to iterate this number of time. You just output a space. And followed by another loop, output symbols, meaning how many symbols we want to output. We do the same thing. Last but not least, adjust the value of spaces and symbols. Look, after each row, the number of space will decrease by 1, and the amount of symbol will increment by 2. So this is what we are doing. Number of space minus 1, number of symbol plus 2. And when we put everything together, look, these are the 5 steps. I'm solving it step by step. Solve it, solve it, solve it, solve it, solve it. And then when I put everything together, this is what I have. I have the full problem solution. And this is exactly the essence of stepwise refinement. And by using stepwise refinement, it just makes our life better in terms of how we solve a problem. So this is when I put everything together. If you notice, I also include command. So this is the line of code that the computer won't execute, but then it is there just to let the reader of the code knows what this chunk of code is doing. So that's stepwise refinement. To make stepwise refinement easier to use, we will be introducing what module is. And this is another incredible useful way of writing program. Stepwise refinement helps us to decompose a big problem. Again, stepwise smaller subtasks. And these subtasks can be encapsulated into a module. Module can get called whenever its functionality is needed. So we're going to look into 2 different types of modules, procedure and function. The only difference is that procedure does not return a value and function returns one. You might feel confused, but let me explain. Be patient. Procedure. So this is the structure for a procedure. You write down the procedure keyword and procedure. What is the name of the procedure? And you put in the code that you want to include in this procedure. And I want to go back to the pyramid drawing question to help you understand the power of procedure. So this is the code that we have written just now. We ask the user for symbol, max number of symbols, blah, 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 and then draw a pyramid. And as we have explored just now, many of this line of code, they are subtasks. So this is a subtask. This is another subtask, 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 subtask. And the idea of module is that we put these subtasks into a place, and then we call them whenever we want to. For example, I'm going to put the set value subtask into a procedure, meaning I put every line, all the line of code here, I put it inside this procedure called set value, meaning all the codes under this procedure, they are related to setting the value. And of course, inside a procedure, you can also call another procedure. Look, input max number of symbols. This is another subtask. So I'm going to create another procedure called input max number of symbols. I will put the line of code here, move it from here all the way to here. And then I will call it. This is how we call the program. And I will do the spaces. And I'm going to continue to split each part of the code into their subtasks. It's nothing complicated. I just copy everything into this procedure. And but I'll give it a name called output space, meaning this procedure will do all the tasks related to outputting spaces. Another, output symbols. another adjust value for the next row. Look, once I have put all this code into the procedure, that's the power of it. I can now first write down all the procedure I need, and then in the main program, I'll just call this procedure. Think of call like an instruction, a set of instruction. I've grouped a set of instruction, and whenever I want to use them, I just call them. Like in this program, I'll do call set value, and what a computer will do is that it will go to whatever is set value and execute the code 1, 2, 3, 4, and then go back. And I'll repeat call outer spaces, go here, run, call output symbol. And by using modules like that, you can see that our code is a lot neater. Because when we look at this code here, we might not know, which line of code is a subtask and which line of code are not a subtask. But then when we group these steps together into procedure, then everything becomes clearer. Output spaces, output symbols, and it also make your code look very organized. So this is what module is. It's important when your program has millions of lines of code. So that's what I want you all to learn today. So next, let's look into function. It's the same thing as procedure. The concept is the same. They group together similar instruction, and we call them when we need. The only difference is this thing, return. They return a value, and when you are declaring a function like that, you need to specify what is the data type of this function that is returning. For example, I can write a function that calculates and returns the sum of all numbers from 1 to 100, meaning I sum the value of 1, 2, 3, 4, 5, 6 until 100. So look, the only difference is that I do all this thing, total, use a for loop to sum them all up, adding whatever the counter is to the total. And instead of outputting the total, I will return the total. And because the total is an integer, I'm putting integer here as the keyword. So when you return a value, it can be used by the caller. What I mean, I've had an example here. Look, if I want to write a function that calculates and returns the sum of all numbers from 1 to n, this is the function that I can write. And before that, you need to know what parameter is. So a parameter in a function is a variable used to receive and store value passed to the function when it's called. Meaning you can pass in a value, for example, sum to n function. I can pass a value n into the function to let the function know what is the value of n. And in this case, I will just call sum to n, and I put 5 into the parameter, meaning I want to find the value from 1 all the way to 5. It's called sum to 5. And the power of function is that it will return a value. So the total variable, once it's returned to the caller, it will be reassigned to this variable that I created. Whereas a procedure cannot do that because they cannot return a value. So in this case, I can use sum to n, but I put in 10 as the parameter value. And in this case, the function will then return the value from the sum value from 1 to 10. This is another benefit of using a function or procedure, is that you don't need to repeat the code. Because once you declare the function, you can call it again and again, multiple times. So that's another benefit of a function. We'll learn more in chapter 14 when we learn programming. So the last slide of the day is to introduce to you what global and local variable is. So we have learned what variable is. It's a box that stores a value. And a local variable is a variable that is created inside a module, a function, a procedure or function. And this variable, like count1, it's created inside this procedure. This is why you can only use this variable in the function. That's why it's called local variable. I mean, you can't access the value of this variable outside the function. Whereas a global variable is a variable that is accessible from all modules. Look, if I have created this variable called x equal to 5, and then this is what we call a local variable because it's not a variable created inside the function. And the good thing about global variable is that you can use it anywhere. So if I were to output x here, I can do it because it is a global variable. And that's all about it for algorithm and problem solving. It has been a very, very long video. And if you watch until here, thank you so much for watching. I'll see you in the next video. Goodbye.